All right, so this is the content overview for the Gear Up San Diego Summer Institute 2016. So we're going to hear a little bit from Ivan on some of the content, and then I will give a quick overview of some of the coaching
Hey, Manuel.
and changes. So, all
We
righty?
are online for our meeting today. I'm going to forward the email from Chris.
So I'm going to ask you to all mute your microphone.
Okay.
So call me if you want to know more. Apparently they're having trouble reaching you on the iCloud email. You might not have received his email. So I am going to forward his email to you. Okay?
Okay, Terry, if you could put
to
yourself
your
mute.
LAUSD account, because I don't know what other email to use. Okay? If you can, get online as soon as you can. We're waiting. But he's going to get started.
Terry, will you mute your microphone so that way we can...
Oh, I'm sorry. Did you hear me talking to Manuel?
Oh, sorry. Got all that recorded, so now you are archived for eternity.
Sorry very much. Sorry for that.
Oh, okay. That was not a problem. Oh,
no.
Yeah.
Okay, now we're just waiting for Ivan. Ivan got himself in a side conversation.
Yeah. So sorry.
One of the things that Sharon mentioned is that she didn't have Manuel's other email. So I will send it to you when we're done.
Okay, thank you. Perfect. Okay, welcome everyone, and let me introduce you to this year's content for the San Diego Gear Up project over the 3 days. So as you all know, last year's content was focused on ratios and proportional relationships, and this year we're going to bridge from that into linear relationships in general. So last year, if you think of it this way as y equals mx, this year we're going to expand that to y equals mx plus b. And then from there, we're going to move into expressions and equations, where we talk about how, Manuel has 4 more apples than Terry, that kind of stuff. And then from there, we go to equations, how to solve equations in one variable. And I'm trying to link all of those together from last year all the way into equations. So it's an ambitious institute, but the real focus is how to help teachers learn how to fish for themselves rather than just give them a bunch of fish to eat. So while it's ambitious in terms of the scope, the underlying theme is really about how to build your own. What's the thought process behind the construction of each of these activities? A lot of the conversation will be to sort of go inside my head, which is dangerous in itself, but to go inside my head and to look at what was I thinking when I built some of these activities, and then to encourage them to build their own as well as to modify what they see, because ultimately they have to implement it, not just what we give them, but implement their own creations. So that's the big picture. And I'm going to just launch into some of these examples that you've already seen, and hopefully they'll help you understand where we're going with all of this. On day 1, that's the bridging day, where we look at some example problems that are proportional and then comparing that to problems that are linear but not proportional. So the first activity is one called ratios connections, or ratio connections, and this works in conjunction with a GeoGebra app that I put together so that the teachers can see how the slope of a line, as illustrated by those triangles, the triangle slopes, right? The slope triangles, is also the ratio of the height of the triangle to the width of the triangle. So picture a line going through 0, 0, right, any line, and then from some point on the line to the x-axis, that vertical distance is the height of that triangle, and then from there to 0, 0 is the width of that triangle. Well, that height to width ratio is the slope, right? But if you extend that triangle out so that the base is 100, then the height becomes, it's proportional, of course, but the height is now the percent. So that hopefully the teachers can see how the ratio of a right triangle is also similar to the ratio, the percent ratio. And then if you go all the way and zoom in to where the base is 1, then the height of that triangle is the unit rate. So this is a dynamic thing where kids can slide the base and the height, and then they can see that no matter what they do, there's a proportional right triangle that is the percent, and a proportional right triangle that is the unit rate. And so this activity that you see here called racial connections helps teachers and kids recognize how these ideas are all connected. So the first row, and part of this is, I'm spending more time on this one because this is where a lot of the thinking behind activities is unearthed. So if you look at example 1, the first row, the context is you get 3 points for every 1 homework problem. So the idea is that kids will set up a ratio of 3/1. They fill out the table, and then from there they see the ratio of y to x, because this is a proportional relationship. Y to x is also 3/1, right? And then solving for y, you end up with the equation y equals 3/1 times x. Now, they don't have to know how to solve it analytically, because they can also derive this relationship of y equals something times x by looking at the table, right? The y value is always 3 times the x value. So essentially, they can backwards solve this and realize that there's this relationship between y and x. And hopefully, this makes sense to you. So the second row is doing the same exact thing, except now you're getting 3 points for every 4 homework assignments. And the intent here is that the kids can see how instead of a 1, it's now a 4, but the math is the same. So ultimately, at the far right box, y equals 3/4 x instead of y equals 3/1 x, right? And then the third row takes it to the next step using the same 2 numbers, 3 and 4. So the ratio is 3/4, but then asking kids, based on that ratio, so taking away the table, but still using the table sort of, what would it be for 40 questions? So the kids can see that it's 30. What would it be for 60? What would it be for 100? And obviously, the 100 is on purpose because that's where you get your percent. So they can set it up in the third box. 75/100 is the same as 3/4. And using the same pattern, that means that the p, which is a 75, in general, p/100 is, in this case, 3/4 times 100. So this is intended to help the teachers and the kids see this connection between ratios and proportions, slope, percents, and unit rate. That's sort of an opening activity. From there, we move into activities where I want them to see the idea of independent variable and dependent variable, because eventually we're moving into activities that are linear and, in general, and not just proportional. So this one, of course, is still proportional, but I also want to instill in the kids an understanding of what dependency is, right? And there's a mathematical understanding of dependency, but there's also kind of a intuitive understanding of dependency. In this particular case, I'm saying to the kids, you get 5 points for every day that you attend. So how many points you get depends on how many days you attend class. And so the kids begin to see how this second number, is tied to the first number. So the dependent variable, it represents all the numbers that depend on whatever the independent variable is. Anyway, that's just to kind of introduce the concept. But again, bridging using proportional relationships as the bridge. And by the way, stop me anytime you have a question or an observation or an insight. So from there, I want, there's an activity.
Ivan, I have a question.
Sure.
On the worksheet from before,
Mm-hmm.
number 1, when you look at the table, you just have X, Y, but you haven't made any connection as to what X represents. Is it the homework or is it the points? And what does Y represent? I mean, I know because of what you have there, but they could get it the other way.
You're right.
You're
right. But I pre-populated the table with one row, so
right.
So that's a great conversation that we need to have, and version 2.0 should probably clarify that, but I'm glad you pointed that out. And so the pre-populated table does show 3 in the Y column and 1 in the X column. So when you set up the ratio, it's implied that 3 is the number of points and 1 is the number of homeworks. But you're right, it's not explicitly.
Yeah. I was thinking more about the 6th grade teachers. You're
right. Absolutely. So this would be something I would hope that when we meet in San Diego, you raise your hand, say exactly that, and raise the conversation, right? Because it's not on the printed version, so I'm going to count on you to remember that, to bring that up, and then we can have a conversation around that. But that's perfect. I'm glad you did that. Thank you for doing that. Okay, so then this leads us to an activity that we may or may not do, which is the dependent-independent variable activity that involves pasting in various cards onto a sheet to sort of see which ones are connected to each other. And that's the reason I say may or may not. It depends on whether or not Robin has thrown away the pieces from our Central Valley Gear Up. In between Central Valley and San Diego, Robin has collected all of the handouts and bound them together into a single notebook. So they're not separate handouts anymore. And when we had them as separate handouts, we could cut them out and do things. But now it's bound into a book, so there's stuff on the back side that you can't, if you cut it out, then we lose it. So I don't know, and we did have some cutout pieces left over from Central Valley. I just don't know if they're still accessible to us or if they've chucked them. They were all in this Ziploc bag, and I've asked Robin to look into it. So this activity we may or may not do. If we don't do it, I'll just show it to them, and then we'll move on. And then finally, on day 1, there's one more activity, because we don't have a lot of time on day 1. The bulk of our time will be spent examining the MDTP. Ann Trescott is a phenomenal presenter, and she's going to talk, spend about 3 hours on Monday about this, the MDTP and the uses of it. So that's why the math is kind of truncated on Monday, but it'll all come back on Tuesday. So the final activity I have on Monday is this activity called using tables. And the idea behind using tables is to kind of give them a preview of where we're going with all of this stuff. Like, why am I showing them proportional relationships and linear relationships when at the end of the day we're going to be looking at expressions and equations? How do they tie together? And this particular activity is intended to highlight those connections. So if you look at this activity called using tables, you'll see that there are 4 tables, and each of them is sort of motivated by a phrase such as Tom has 4 more candies than Jerry. Right? That's the first table. So there's some pre-populated numbers, and then based on that, the kids are supposed to fill in the empty cells. So if Tom has 4 more, that means that whatever Jerry has, the kids are thinking it's got to be 4 times that for Tom. So they fill in that. But then you'll notice in the second section of that table, I give numbers for Tom, and the kids have to figure out what Jerry has. So the idea here is if Tom has 16, what does Jerry have? Because Tom is the one who has more. So then the kids have to think about the reciprocal relationship, right? Or the inverse. So 16, you've got to subtract. And that means that Jerry must have 12. So you're going backwards. And then down below, back and forth with some different numbers. And then there's this box. So what if you don't know what the number is, right? There's a box. and the kids oftentimes will put a number there, and I'll say, well, go ahead, put whatever number you want. And what do you do with that box or the number in the box? Well, if I know what Jerry has, then Tom has to be 4 more than that. But if I know what Tom has, then I got to subtract 4. So that's really the main point here. And then next to it, problem 2, where Maria is 3 times older than Juan, this is now slightly different. This is now a proportional relationship, and the kids have to learn or to recognize that I got to multiply or divide versus add and subtract. Does that make sense? I mean, I'm hoping that that makes sense to all of you. Thank you. So basically, the 4 problems here is a preview of where we're going to go on Wednesday with all of this math. And that pretty much is what we're focusing in on for Monday. And then after our afternoon break, we're going to spend our time, you folks are going to work with your teachers to sort of think through, now, what does this mean for us? How do we apply it to our curriculum? Where are the places where our kids are struggling, and how can we begin to think about ways to support that? So it's really identifying where the problems may come up and what are some possible things we might want to do. And even based on the activities that they just got, how can we modify them or even use them in our curriculum, like as a supplement? So that's Monday. Any comments or questions on Monday? So you're all silent. I'm guessing that means you're fine. Either that or you're all on mute and you can't unmute. So on Tuesday, we have 2 key sets of activities that I want to get into. One is linear functions in general, and the second is expressions and ways to represent expressions. So in terms of bridging from proportional relationships to non-proportional linear relationships, I've got activities such as, well, first I'll talk a little bit about slope. So I've got some slope connection problems, which is essentially, working still with proportions, but helping kids understand the slope aspect of these proportional relationships. And so activities like slope connections ask kids to graph, to make tables, and then to recognize how the number in the equation, that's the coefficient, is related to what we call rise and run in the graph, and to the constant rates of change in the table. So slope connections and also finding slopes. So you'll notice that in finding slopes, that set of activities directs kids to analyze slope with various starting points. So part A gives them the equation, and then they have to make a table and draw the graph. Part B gives them the graph, and from that they have to make a table and the equation. Part C gives them the table, and they have to do the equation and the graph. And part D gives them 2 coordinate pairs, and they're supposed to come up with everything else from that. And then on the back side, there are 2 lines that happen to be perpendicular, but that's not the main point. The main point is that the slope between all collinear points are the same. So from A to B, or B to C, or A to C, or A to D, or B to D, all of those have the same slope. So if the kids figure out one, they automatically have all the rest. And that's
which worksheet are you on?
Finding slopes.
Finding slopes. On day 2?
Day 2, yes.
Thank you. Oh, I don't see one called that.
Got it?
I don't see that one called.
It's in day 1. It's in day 1, Ivan.
It's in day 1.
It's in the day 1 folder.
Oh, okay. Thank you.
Okay.
There it is. There.
The agenda has shifted so that it is being presented on day 2, but I guess when we set it up, it was sent off in day 1. Thank you, Chris. Comments or questions? Okay, I see the thumbs up from Bob. Okay, I'm going to move on. And are we, just to clarify, is the Super Bowl activity on day two's folder, or in day two's folder? Yes, no? Chris?
No, it's in day one still.
Okay. It also got moved to day two. So I'm looking at my folders in the reorganized manner based on the agenda that we have revised for San Diego. But yeah, you're probably finding it in the different.
Should we send, if you have that, do you want to resend that out to the coaches and myself?
The agenda?
The agenda with the reorganized folders?
I could, yeah.
I don't know. It might help just
all the files
for clarification.
So you want all the files, right?
Right. Your zipped folders, your reorganized zip folders, and then the agenda.
Okay. I'll do that as soon as we're done with the call, and I have to reorganize a few things for me because I have more stuff in it than just the folders. I have other things that I put in for myself in terms of preparing all of this. Okay. Yeah. So we're in day two, and in particular, in day two, I'm going to have them work and actually do the work on the Super Bowl problem. Now, the Warriors problem is identical to the Super Bowl problem. The only difference is the Super Bowl problem has a table that's been sort of partially populated to guide the kids' thinking. The Warriors version of that same problem is completely blank. So there's a space, a rectangular space for kids to do whatever thinking they want to do, whether it's drawing tally marks or drawing pictures, and then the table and graph to make sense of the problem. So in this particular problem, the Super Bowl Warriors problem, the context is that you and 3 of your family members invite friends over for a party, and the doorbell rings and 5 people show up. In fact, every time the doorbell rings, 5 more people show up. So how much pizza do you need to get for all your guests, right? You kind of have to think about that. And the controversy, the small controversy that comes up is at 0 is the y value, at x equals 0, is the y value going to be 3 or 4? And then the kids have to think about, oh, you and 3 members of your family. So you know, some people will have started with 3, other people will have 4. But the beauty of that discrepancy is you point out how important that initial value is and how that initial value will impact the entire table or the graph throughout, right? Because I'm ultimately slowly moving towards this idea of the y-intercept, but I'm not using that yet. I just want kids to talk about what's going on here, what makes a difference, does the 3 matter, does the 4 matter, etc. The activity that follows that is called intercept problems, and it's a collection of problems that all involve the intercept without me naming it. So the opening one is called field trip problem, and the field trip problem has 4 buses all loading kids on a field trip, and they're loading them at the same rate, 5 kids per minute. So that's not the issue, right? Because in all 4 cases, the rate is the same. What is different, and I'm going to ask the teachers to notice it, is that the number of people on each bus to begin with differ, right? The first bus has 0 people on board, the second bus has 4, the third bus has 5, and the last bus has 10. And then when they plot the graphs on the graph paper or on any graph paper actually, they'll see that there are essentially 4 parallel lines and that have different points on the y-axis. And that point corresponds to the number of people on the bus to begin with. And that point on the y-axis corresponds to the first row of each table where the x is 0. So I'm trying to get kids to sort of see this connection between the point on the y-axis, the initial value of the table, and the context, which is how many people are on the bus to begin with before kids get on board, right? It's a very intuitive look at this y-intercept. And so it's not just a graphical interpretation, it's a contextual and tabular interpretation. And the problem that I'm trying to address is that a lot of times we tell kids y-intercept, we're only thinking about the physical location of that point, and it's stripped away from contextual connections. So this is meant to build that connection. What this leads to then is an activity called finding rules. So finding rules takes it to the abstract level with no context. So now kids are beginning to make links between this point that falls on the y-axis and the row where x is 0 in a table, and also with the context of the starting point. But now I want kids to see it as the plus b. Where does this show up? Because ultimately I want them to develop the y equals mx plus b. And so you'll see the table on finding rules, and it's got some numbers pre-populated, and the intentionality there is I don't want kids to do wrong arithmetic and then they don't see the pattern. So that's why I give them the numbers, because I want them to see what's going on with the numbers. They can plot those points and see that it's linear, right? But obviously 0, 2 is not going to, that's where the graph will cross the y-axis. And then I'm asking kids to tell me what y is when x is 100. Clearly, the graph is not big enough. So now they have to think about the math. What math do I have to apply here? So based on the pattern, I hope the kids can come up with the, what the slope, the slope of course is 3/1, so that they can see that the pattern is 300 plus 2. And then the final one with 200 there, it's 600 plus 2, right? That plus 2 is really important. And then ultimately, the questions below guide them towards recognizing that. So what is the slope? They see that it's 3/1. What's the rule? Well, that's where they have to figure it out. And then, of course, they have to circle different places where the slope appears, where the intercept appears, and then finally by step 9, I call it the name, y-intercept. So this is where I begin to formalize the thinking as opposed to starting here as most textbooks typically do. And if you think about the progression, we started on Monday with proportional relationships and how that's tied in with ratios and percents and all those concepts that are generally not connected. And then from there into linear relationships, and from there into this formalization of the y-intercept. And then from here, the kids can go into the book, right? Now they're ready to do problems that involve y-intercepts. But if you just start with where the books are at, kids are already lost because they have no foundation for this concept of y-intercept. And then we're going to transition to some activities. And unfortunately, Enchante won't be here. She's developed some very nice activities to take this to the next level of functions and asking the teachers to think about what functions are and what makes a function and how these linear relationships are one type of a function, right? It's not the only function out there. And then also introducing Desmos and how Desmos can be a useful tool in visualizing functions, particularly with explorations that use the slider. And that'll take us up to lunchtime on Tuesday. After lunch, we're going to switch gears and address expressions and equations. Primarily expressions on Tuesday and moving into equations on Wednesday. The reason is that we want to move to this is that there are these linkages between expressions and what we have just done, as I foreshadowed on Monday. One of the problems that I find with kids doing expressions is that the symbolic representations are often very, very confusing for kids. They don't understand how x or 3x or 5x or x plus 5 can represent some of these contextual relationships. So I begin with picture this. Picture this is meant to guide kids to see a visual relationship. How if you click open picture this, Sarah and her friend Jackie go shopping, and Jackie spent 4 times as much. Pictorially, there's a sort of a empty rectangle. You can show that Jackie has 4 times 4 boxes, right? If the shaded square is what Sarah spent, then Jackie is 4 times that. This is in contrast, next to it, the idea of 4 more. And how's that different? So 4 times is literally, 4 boxes. 4 more is not 4 boxes. So the kids have to figure out another way to represent 4 more. So sometimes they put tick marks, or they'll put dots, or they'll put dollar signs, or whatever, but some way to show 4 more is not the same as 4 times. And that's really the key, is to begin to learn how to differentiate between these 2 terms, which are very confusing for kids. So using a pictorial approach to highlight the differences before having them write it using symbols like x and 4x or x plus 4. Does that make sense? I'm hoping that this is something that kids, I've used it with kids and they seem to catch on pretty nicely. And as you progress through this particular handout, you'll see that gradually more and more of it is taken away, so that finally on the last page, there's a context, and then the kids have to figure out how to draw it themselves. Use a picture to draw this. And I'm not even asking them particularly to solve. Solving it is an option, but really in this case, it's to represent. Learn how to represent. And that's called Picture This. That's the name of this activity. The next few activities follow this pattern where the kids are asked to basically draw pictures and write the symbolic expression. And if you go into more, or into, it's called More Expressions, the file that's called More Expressions, you'll see something else going on. Now I group them in sections of 4. I'm not just having a contrast between 4 more or 4 times. Now I've got, in this particular example, the first one being William and his Pokemon cards, I've got 3 times, 3 more, 1/3 as much, and 3 less. All 4 variations of using 3 are involved here, because I want kids to be able to distinguish between the 4 of them and how they look different depending on what words are used, right? And these are some key ideas. Another concept I want to mention, I'll get to that. That's coming up later on, is the difference between, the reciprocal relationship shows up here. If I have 3 more than someone, then that person has 3 less than me. The other relationship I want to point out is that when William has 3 more than Raul, it's not W plus 3 equals R. The kids need to realize that, and the pictures hopefully illustrate it. So having a pictorial relationship helps kids see that you don't add 3 to William just because the words appear in that order. And that's a really important thing to convey, and it's also a source of confusion for a lot of kids.
I was going to say something. I watched a first grade teacher do her warm-up similar to this, where she did 4 more than 5 or 6, 4 less than 6, and she kept doing that. That was her warm-up. So this is good. I mean, it could be a warm-up too,
Absolutely. They could use it in lots of different ways. So to seal the deal on this one, please open Expression Problems. So Expression Problems really, really now takes it from the pictorial to the symbolic. But this will bridge that. So if you just take a look at problem 1, it'll give you a sense of where this is going with it, right? Suppose Marco has the same amount of money as Edgar. So I asked the kids to picture this scenario. And if you use M for how much money Marco has and E for how much money Edgar has, how would you write an equation to show this equality? So the kids, pretty easily, they write M equals E, right? So that's not too hard. Then the second part of that question says, suppose Marco has $5 more than Edgar. So one guy has more. Marco has more money. Who do you need to give money to in order to make them equal again? So the kids recognize, I got to give $5 to Edgar, not to Marco. Marco already has more money, right? So now they're thinking about it in a very intuitive way. So how would you write that as an equation? So now the kids see that M equals E plus 5, because you got to give the $5 to Edgar.
Ivan,
Yes.
on the worksheets, you want to change Armando to Edgar.
It's already been changed. So you have
Oh, okay.
a version. Yeah.
Okay, no problem.
Thank you. I'm glad you noticed that. Yeah, we fixed that already. I think we lost Gretchen. So the idea here is helping kids develop this understanding of relationships and not just blindly, if you look at sentences like Marco has $5 more than Edgar, many kids will simply just go 5 plus M plus 5 equals E, right? That's what kids do. But it doesn't make sense, because if Marco has $5 more, you need to give 5 to Edgar. And this is what helps flesh that out, because now we're moving into symbolic. And no more pictures, right? We want kids to understand the meaning of these words and the symbols that go with that. So that takes care of, I believe, that we're done Tuesday now. And then Tuesday afternoon, following this, we're going to give you and your team a significant amount of time, about an hour or so, to actually, again, map out what's going to happen in your textbooks and where you need to do something like this to help kids. You can use it as is, you can modify it, or you can create your own. The idea is, where do kids typically struggle, so they can tag them, put some Post-its in, so that when you do meet with them during the semester, you have a place to start. Like, okay, we might want to visit this as our first priority, or when we're done with this one, we'll do another one. We just got done doing a session today. I'm in Long Beach right now with the CAP group, and already one group has, just in the 3 days, created 2 brand new activities they were inspired by the stuff they saw, and they had ideas of their own, so they created 2 brand new activities that they shared with the group. So that's powerful. If your team catches the virus and they want to start doing it, by all means, encourage that, because ultimately we want them and you to co-create what works for them, and not just use what's been given. Even if they like it, we want to push them towards the higher level. So that's Tuesday. Now Wednesday we come in and we're really going to move into equations. But before we do that, I'm going to give them the hexagon train task. And that's an important one to start with, because it allows teachers to see that there are multiple ways of visualizing numerical relationships. And so if you look at the hexagon train task, different people will use different things to kind of generate a formula, and at the end of the day, they're all the same when they simplify them. And it does involve distributive property eventually, which leads me to the next activity of floor tiling, which is really a stepping stone towards distributive property. And with the floor tiling, it starts with numeric examples, right? Numerical examples, and then ultimately at the very bottom, there's some black splotches there. It forces kids to say, well, I don't know what the numbers are, so I have to use something else in place of those numbers. And that's where the variable comes in. But the mathematics is the same. It's still, it's using the area model to help convey the idea of distributive property. I hope that makes sense to you guys. And then the activity called RTC Distributive Property is actually in response to some teachers working with their kids on distributive property. I was facilitating a RTC session and came up with this worksheet with those teachers in the moment because they wanted to address particular issues that they saw. And I'm going to ask the teachers and you to look at that and think, what were the issues that prompted us to make this handout? So it's really, again, going into the thinking process of when these activities are made, they're not just sort of made out of the thin blue air. There were some things that drove us to come up with it, and I wanted teachers to analyze.
Which handout was that?
That's called RTC Distributive Property.
RTC Distributive. Okay, let me find it.
It may or may not have a number in front of it.
It's in the day 2 folder.
Oh,
okay.
Okay, thank you.
So the days are messed up in the way that you got them, and I apologize for that. Things changed over the summer.
I understand.
Yeah. Okay.
Yep.
And then based on that, then we move into something called area multiplication 1. And here we're, again, using the area model, but connecting it to the stacked multiplication approach, as well as a symbolic distributive property approach, so that the kids can see how they're all connected. And ultimately, this is going to lead us, you all know this from your professional experience, ultimately this is intended to build a foundation for multiplying binomials, even though we're not doing that here, right? But it's building a foundation. So I really wanted the teachers to see this arc of how we start with floor tiling that uses numbers, and then connecting it still with numbers, but setting the foundation for multiplying binomials. We're not going to go into binomials at all, but this is sort of the stepping stone towards that. So it's really important that they see that things like distributive property aren't taught as an end in themselves, right? Distributive property is a means to an end. And mathematics should not be seen as isolated topics to be learned for their own sake, but that they are learned as tools for making connections and for solving problems. So the mantra I use is teach math as tools, not as topics, right? Tools, not topics. So then this leads me to the next set of problems, which is having to do with the idea of combining like terms. And combining like terms has been very, very problematic, as simple as it seems to us. And I've tried all the techniques. You have kids, put a square around all the square terms, and you put 3 lines under the cube terms, and then you combine the ones with the 3 lines, and the kids still mess up. I go home thinking I nailed it, and the next day it's horrible. So in response to that, came up with a new different approach to it, which is putting things vertically and into these bins, if you will. And this is sort of reminiscent of place value. Kids understand place value, right? Tens place, hundreds place, thousands, tenths, hundredths. So what if we treated terms, the monomial terms, like place value? So you put all the x squareds in the same column, you put all the x's in the same column, and the kids physically have to write that. So you give them a string of a polynomial string of different monomials, and they have to rearrange them vertically. So all the x squareds go in one, all the x's go in one, etc. And so the expressions for bins, the activity is you cut them out. Kids pull out these expressions, and they have to combine them. Well, how do you combine them? You have to take whatever's in them and put them into their proper columns, and that's what the bin is for. And that's how the activity works, to teach kids to organize terms vertically, stacked above each other. And it doesn't matter what order they're in, as long as they're in the same bin. that leads us to a worksheet called, it's called adding polynomials. And this should be in day 3, right, Chris? No? Day 2? Okay. Adding polynomials in day 2. You'll see that I've prearranged these columns, right? So there's a polynomial called 4x plus 2x squared plus 3, and then they have to rearrange them in their proper columns. And then the kids can add vertically the columns. And when they do that, they understand that the x squared column is x squared. It's all x squared. It's really just the coefficients that they have to add. And if you go down that document and you keep going, eventually you'll see some pretty complex polynomials that they have to add together. They see it horizontally like they normally see it in a textbook, but then also some scaffolding to help them rearrange and add vertically. And then finally, at the very bottom, you'll see 2 examples of pretty complex polynomials, right? And they have to combine like terms. Now, they can choose to stack them up vertically, or by now, if they understand how to do it, they can just do it themselves, however they do it. But the vertical method, I found, has helped a lot of kids who typically struggle. Just stack them up vertically in their proper places, and it takes away a lot of the issues that they have. Okay? From there, we move into expanding monomials 1. And here, it's the idea of how do you, now, we may or may not get to this. Just, I'm giving you a heads up. Gretchen has left the conversation. I was going to ask her if she remembered if we got to it or not. This summer, I've been all over the map, so I don't know who I said what to. So this one may or may not have been done in Central Valley. But expanding monomials, I give kids the answer, x to the 8th, and I'm asking kids to come up with 2 monomials that multiply to get x to the 8th. And you all know where this is going to go, right? Kids will put x squared times x to the 4th. That's a very common thing. So then below, they check themselves. They expand it out. So x squared is x times x. And then x to the 6th, they're going to obviously have 6 factors of x. And then when they put them together, they're going to see that they're only, it's not going to be, x to the 4th. So they're going to only have 6 instead of 8 x's. And so they get to try it again and again. And obviously, there are multiple ways to get x to the 8th, right? You can have x to the 3rd times x to the 5th. You can have x to the 1st times x to the 7th, or 4 and 4. Lots of different ways. So we want to make sure kids can see that there are multiple ways to get x to the 8th. It's not just one way. And that's intended to help kids visualize what's going on here. And eventually, we give kids answers, and we want them to come up with the different terms that will generate that answer. And that's a really important strategy for helping our kids. And then at the end of that section, we have something called it's called write your own polynomials, which is adding and subtracting polynomials. And you'll see the same process. There's an answer given, and the kids have to figure out, what do I have to put in these boxes so that I can end up with that answer? Does that make sense? This approach? So we're going to do some of these, and some of these we're just going to talk about. But ultimately, we want to analyze the sort of the thinking behind the design. Why were these activities designed this way? And what does this design provide for the kids versus the traditional textbook design of problems? How does this differ from what they normally see in a textbook? What more does this offer? So these are the key questions we want to prompt the teachers to think about, because that's what they're going to have to do with you, right? They're going to create stuff that's different than what's in the book, or modify what's in the book to reach the kids. And then, moving forward, we're going to get into some solving of equations. And in fact, I'm just going to skip ahead to what's called equivalent equations 1, 2, 3. Hopefully you see where that is. Is that day 3, Chris? Okay, great. So now we're in day 3, And this set of representations is to show side by side the pictorial and the symbolic, because I want kids to be able to see how the symbols can be used to represent something that's more intuitive. And I find that using algebra tiles may be a good way to start, but it's cumbersome. We need to wean them off the physical model into something a little faster. So if kids can draw faster than use tiles, that will be one step closer to the symbols, right? Ultimately, it's the symbols that we want kids to be able to work with. So if you look at this transition on page 1, where I give on the left side the scale picture, and then on the right side the equivalent expression, I'm asking kids to notice something about what's going on. So in the second row, there are two scales. One has a box and 6 equals 12, right? And next to it, you'll see the equation. And then below that is the box equal to 6. Something's happened. Describe what's going on. And the kids can visually see that on the left side of the scale, the weight of 6 is gone. And the right side is reduced down to 6. What's going on here? What's happening here? So then they can see that they subtracted 6 from both sides. Whereas the row below that, I have a stack of 3 boxes, and then it turns into just one box. What happened here, right? It went from 3 to 1. And though similarly, the weight went from 12 to 4. How did you do that? What mathematically did I do to get here? So the kids generate that, and, oh, I had to divide by 3. So I had to split the 12 among the 3 boxes. So each box has 4. So it's a splitting or dividing process. So they begin to see that. And I found that stacking boxes is visually more intuitive than horizontal. They see the vertical, for some reason, better. So 3x means very little to them, but a stack of 3 boxes makes sense to them. Ultimately, I want to connect those two. Going forward, you're going to see then that I have a more sort of a schematic-y type drawing of the scale. The next page, not the page immediately after, because I want to give teachers the option to either have pre-written equations or blank boxes where the kids have to write the equations. But when I start doing the problem, it's called equivalent equations 1A. You'll see that I have a scale with 21 equals a box plus 9, and the kids have to figure out what goes in the box, right? And they can use guess and check, and they can use, thinking backwards, like I have to subtract 9 or whatever it is. But I'm trying to develop an intuitive understanding of what it means to solve for x. And you'll see that as you progress through these, they do get a little more complex as you go. Eventually, you'll have a stack of 4x, for example. 43 equals 4x plus 7, things like that. That's just packet 1. But if you look at packet 2 and 3, equivalent equations 2 and 3, you're going to see that the problems get much more complex. And I'm going to have combining like terms now, and how that affects the problem. And I'm even moving into having stacks of boxes on both sides of the scale. And what does that mean, right? Terms with x's on both sides. So they visualize it and they solve it. And yeah, if you work through that, you're going to see a variety of types of equations. The goal is for the teachers to recognize the process you have to go through to help kids be successful. Yeah, it takes you maybe 3 or 4 days to do these various packets, but by the time you're done, the kids have essentially 100% proficiency. How cool is that, right? You invest this kind of time, and you're going to make sure this will ensure the kids will nail it. And I find that to be pretty motivating for a teacher, as opposed to the same old methods of teaching, which is I explain to you how to do it symbolically, and the kids are lost. This eventually leads us into equivalent equations 3. And if you just look at 3a, you're going to see these red dotted lines, right? And those group x plus 1, which of course leads us to distributive property. So problems that involve 2 groups of x plus 1 equals 16, right? And what's the big problem with distributive property is the kids fail to distribute correctly. So if I wrote 2x plus 1, many times kids will just multiply the 2 and the x, but they fail to do the 2 times the 1. Here, in this example, you're going to see a stack, right? But you also see the grouping, so they'll see that I got 2 x's and I got 2 plus 1's. Then that equals 16. They can also solve it by saying if I have 2 groups equal to 16, then 1 group is equal to 8. A lot of times kids don't see that they can also solve problems. If, before distributing, you can actually divide if it's divisible. And that's the whole point of these activities for distributive property. And you'll see that it eventually gets more complex, right? On page 3, I've got one where I got 2 groups of x plus 1 and 3 groups of x minus 1, and then they have to solve that. Yeah, Terry. Unmute. Unmute. Terry, you got to unmute.
It almost it looks like a bridge over to with using algebra tiles.
Yes, yes. Between tiles. Yeah.
Yeah, that's good. I really like this.
Yeah, so it totally is, right? Tiles is a great way to start, but tiles get cumbersome. And especially when you start working towards bigger numbers, more complex numbers, it's all that tile work gets in the way of really understanding. And tile work doesn't translate immediately to symbolic work, right? It takes a while to get to the symbols. This is the bridge to help kids get from tiles to pictures to symbols, because we really want kids to be able to work fluently and proficiently with the symbolic representation. And that's what this is designed to do. And then finally, if there's time, on day 3, I'm going to have them look at what's wrong, which is a error analysis activity, because ultimately I want the kids to be able to look at things symbolically and spot where the mathematical errors are. And that's important for them to learn all of these things. And just as an aside, there's a packet called Word Problem Types. What I've done is I've cataloged all of the problem types that involve rate, time, and distance, and mixture problems. I find that there's so many variations of these that it's helpful to have sort of a comprehensive catalog of all the different types so that teachers can see, okay, which ones have we addressed, which ones have we not addressed yet. And then they also serve as prototypes for them so that they can just look at this one and then change up the story or the context, but at least they know which type that they are addressing. And you and the teachers, as you work with them, can talk about, well, which type do you think the kids are struggling with, and then zero in on that as sort of a reteaching or first teaching. But whatever it is, you now have a sort of a list of different types to look at. And they're not going to work on it. They're just going to look at it and recognize that there are so many different types. And that's really it for our work for San Diego. I'm looking forward to it. It's pretty exciting. So comments and questions. You can unmute.
I appreciate seeing it ahead of time. It makes it much easier for me to see the flow and what I need to be thinking about.
Yeah.
Really appreciate that.
Yeah, it's so that they can see the arc, right? So
but also it helps me now to start thinking a week in advance what I want to talk about.
Right.
Chris, I forwarded that to you, by the way.
Thanks, Bob. I got it.
I love this, Ivan. This is wonderful. This is what teachers have been asking for.
Yeah, I'm looking forward to it.
Oh yeah, really, and especially my 8th grade teachers in San Diego because they hate their book.
Yeah.
So
But, you know, our focus this year, Terry, just so you know, our focus this year is that they look at these as prototypes, as models for
Right.
themselves to inspire them to build their own, right? Which is what I was saying earlier, how this CAP group in Long Beach, a couple of teachers just got so jazzed by it, they created their own activities that, you know, is not anything that we covered. They had some specific needs with their own students that they addressed. And you know, they're walking out now with 2 activities they could use for the first day of class.
Yeah, this is more than just a content. I mean, you're covering a lot of content and getting an understanding of the content, and we want students to have that. But for the teachers, it's when they hit something else other than the linear functions and the expressions, equations, something other than that they're teaching, maybe in the geometry or something in statistics or probability. But it's looking at how their textbook approaches it, and a lot of times it's very random or very prescribed in a way that it's just memorization of a process and not necessarily building context and building connections with the mathematics. And then getting the teachers to recognize that as that first step, right? So I think that's we're hopefully have done in the last year and within the Summer Institute, is they recognize that sometimes if they just do this prescribed with their textbooks, they might not be hitting these connections of mathematics that the students really need to see. And so then it's at that point when they get to those places in their textbook to ask those questions of what can I do to build those connections even further and use the ideas and the templates, if you will, that Ivan's been sharing to do that with even other standards and other concepts, so that way their students would have a better understanding of the mathematics as a whole, and even bringing a bridge to each of the contexts, the concepts throughout the year that they teach. So yeah, definitely it's phenomenal, and I'm excited, and hopefully that's what we want to get those teachers to have, is that aha of this is something I need to do with all of my math, not just the standards that are being addressed next week.
Exactly. Well said. So it's going to be pretty exciting. And now, Chris, you're going to co-present.
I am. I will be there, and I will co-present with you, Ivan. We'll have a good time. So
you can do all of this, and I will watch.
Yeah, there you go.
No, we'll have to figure out some ways to make it seamless and smooth.
We will.
There's some stuff here that you haven't had a chance to see implemented yet, right? This is just the overview.
Sure.
Yeah.
Yeah, you bet. I definitely want to be a part of what's going on. So are we good? Any other questions on content? Because I can give a quick overview of the coaching shifts, and then we'll call it good.
Okay. So I'm going to exit, because I need to get back to the Long Beach meetings. Chris, you were in Valley, right? You were in Elk Grove?
I was in Elk Grove, yeah.
So you saw Enchante do the whole functions activity? No, you missed that.
I wasn't there that day.
Oh.
But maybe that's something you and I can talk about on Sunday afternoon, evening, and I can probably get it figured out. I'll look through it. I have been looking through it. I'll look through it even further and play around with it. And that's something I can try to figure out, and then run it by you on Sunday to get some confirmation on the process of what you remember on doing.
Okay, so great talking to all of you, and then you can, I guess, keep. Are you recording still?
I am recording. Yep.
All right, so I'll see you guys on Sunday or Monday, whenever you guys.
Well, I think we're all supposed to be there Sunday at 4 o'clock.
Oh yeah. So I'll see you guys all there.
Yep.
Perfect.
Yep. We'll be there at 4 o'clock. So I'll see you in the afternoon on Sunday.
All right. Thank you so much, guys. Talk to you guys.
Okay. Thanks, Ivan.
Bye.
And Bob, you've seen this coaching stuff. You can stick around if you want to, but it's going to be recorded, and it's up to you. I'm going to go over the actual website, a little bit of changes, and we'll hit it again when we talk to the teachers. Thanks, Bob. Bye. We'll hit it again when I talk to the teachers. So Terry, I'm going to share my screen right now with you, the actual website. So let's see if you can see that. Tell me if you see it. Do you see my web page? Okay, it's kind of squished. I'm going to open it up a little bit. There we go. So this is the home page. So here's the difference when it comes to the things that we've changed for the filling out forms. Basically, the coaching piece of the project. It's the same coaching. It's RTC, but there's different ways that they can get hours now. So, and we kind of touched upon it a little bit in May with the coaches, but this wasn't up and about at that point. So I want to show that. So you go to the teacher's homepage, and on the teacher's homepage, what you'll find is these hot links. So I tried to emphasize certain things that I know the teachers tend to need to find right away and help their navigation. So I'll start from the bottom. The MDT page is now loaded with some, I'll go to it. It's got a nice, right away, a big link. Oops, that go away. A big link on the MDT page that explains specific guidance to what they need to do for access. So it's a nice guidance page for what they need to access, what assessments to administer, and when do I give it, why do I give it, the difference between benchmark and summative, some real specific stuff around what we're doing with MDTP and access, okay? And then there's another hot link here that's called the Library of Math Activities, and that takes them basically to the page that has the Google folder of all the activities that Ivan's going to be doing and showing, along with others that are all in digital form. So that way they can write on their books, and they know they can get a clean copy of it because it's organized alphabetically. So they can get a clean copy of it online and download it. And then the Google Hangout page gives them more information about how to do Google Hangouts. And I'm going to go through this stuff with the teachers on next week. So this is the new piece here, the finding your collaboration form. So if they go to that, how the collaboration forms are, that's not one form for every single teacher and every single project. It's organized by actual project and by teacher, or excuse me, by coach. So right now I haven't hot linked everybody yet because I'm still working on getting it all, but let me just show Bob's form. So it's basically, they would go to, yours will be hot linked very soon. I'm going to get that done tonight, and I'll send you the link to it so you have the access to it. Because when you go to Bob's, or yours in this case, if Bob was their coach, they open up the form, and it's similar to the previous form, but now it's specific to their team with Bob. So they will find their name listed. And then this is the little different part, right? They're going to either do a Google Hangout with you, which is what we've done in the past. And then this is where we have that option of sometimes being in person with them. So it may be an in-person coaching meeting. So we want to know the difference. And then this is that piece where they can do RTC collaboration with colleagues and no coach. So that's when they're looking at MDT data, but then yet making some informed decisions on how to respond to the student needs. So it's an RTC collaboration with just colleagues. So at that point, they can do some collaboration without you there. But there's going to be some accountability to that. If they do that, a couple things have to happen. A, they're going to let us know when it was, whether it was, this date goes for any of these, and the amount of time goes for any of these. And then the focus of the collaboration gives us a little bit of information about what they talked about, what they did, what you guys did. So here's that accountability piece of, if they did it without the coach, they have to commit to a date that they are planning on sending you that activity and the write-up report. There's a new report that, let's see if I can find it. I have it in the folder. There's a new report, and it's on the collaboration page. Let me go back to it. A new report that we've created, and that's it. That's down here at the very bottom of the collaboration page. And we'll again show the teachers this, but I wanted to give you a heads up. It's called a Math Activity Collaborative Efforts Reporting, and it's basically a Word document that they can download, and they basically need to fill this out with their team that they worked with, and then submit this to you along with the actual activity itself. So then that gives you an opportunity to review it, set up a time that you might want to connect with them, or you communicate via email if that works best. So it's that idea of, we're trying to push them now to be doing this collaboration without a coach, but we still have some accountability and some ways to make sure that things are going on track to what makes sense to the work that we're doing. So that's the actual teachers' collaboration forms, and how that's going to work for them filling out their forms. And basically what you'll get to is you're going to get this. I'm going to give you access to the actual data. So you will have real-time data, the real-time spreadsheet of when they fill out the form. It goes, you have access to this. So you'll have access to your own form that'll tell you the timestamp, teacher's name, all of the information they put in that form will come to you and me as well. But you won't have editing rights. In other words, you can't accidentally delete data. You'll have commenting rights. So if there's something that needs to change or you need to communicate with me, you can either email me or comment on this page, and I can make the actual changes if necessary, if something was written wrong or what have you. So it's a little different. Instead of me populating the form that I gave you last year, it's going to be the forms being populated and you have access to it, and then I will pull from it and report to Sharon going the opposite way of reporting. So did that make sense? Let me come back to screen here.
I was going to say, yes, that makes sense. And I can also download it, right, on my own Excel sheet if I want to, just like last time?
Absolutely. So you'll have access then to your own data. You can download it to Excel and do anything you need to do with it. But keep in mind, basically, anytime some teacher gives their inputs in the form, it's live for you. So you keep that link. And so I will be sharing. You'll get an email from me probably tonight, because that's when I'll work on it. An email from me that sharing rights. So you'll have commenting, sharing, viewing rights of your own spreadsheet. Okay. There's one more I want to share. Let's see, where did it go? No. Oh, here it is. There's one more I wanted to share, and that is the form that you fill out. So coaching, in the coaching corner, under coaching forms, that's different as well. You will have your own, and again, I haven't completed it yet, but you'll have your own individual form that you fill out. So you will highlight, here's your name there, it will be linked, right? So you'll have a link here, and it'll link, and I'll go to Bob's again. If I go to Bob's, you'll have one that looks exactly like this, but it'll be specifically for you. And you will also get access to the data you put in. So this is the identical form to what we used last year, but instead of you waiting on me to get you your live data, you'll get it right away. And I also have access to it to pull from to do reporting. So you'll see that. So that's a little different. Every coach will have their own individual form to fill in. And then, of course, we'll have the miscellaneous record timekeeper down below here, too. So you can actually, if it's something that's non-coaching related, if it's a collaboration time, those kind of things, you can count for that time.
And what about these kind of trainings, these coaches hangouts? We used to have a special form.
That's yeah, you would use the miscellaneous form to claim those.
Oh, okay.
Yep.
Got it.
Okay.
Okay.
Any questions?
No. Sounds good.
Cool. Well, then.
It'll work.
Great. Yeah, we're excited. We'll see you on Sunday.
Sunday at 4 o'clock. Thank you.
Thanks, Terry.
We'll see you. Bye-bye.